Let's go ahead and start working on solving and finding inverses. We're going to also, in addition to finding inverses, we're going to practice finding domain and range of both the function and the inverse of the function. So this symbol means the inverse of the function. Okay, so you've learned how to find inverses in the past. Usually the first step is to change this to y equals. And then there are multiple ways of doing this. Some people swap the variables. I just go ahead and tell my students, just solve for x instead. The reason for that is we're actually switching over what the input versus the output is going to be. Okay, so I'm just going to go ahead and solve for x. And I end up with, and I'm going to write it this way, x equals y plus 7 over 5. Okay, so this is your inverse. Typically at this point, inverses are often written in terms of the x, but right now we have it in terms of y, so I'm going to go ahead and write this little inverse notation, and then of y is equal to y plus 7 over 5. You could also write it as f inverse of x, but then you just need to make sure your variable matches whatever is inside here. Okay, so I'm just going to use y as our term since we were solving for x, and every time we do it. So we have our inverse. That is step 1 right here, find the inverse. The second thing they wanted you to find is the domain and range. For functions you know really well, it's going to be really easy to do. So for instance, 5x minus 7 is just a straight line, right? Straight lines have a domain of all real numbers, and they also have a range of all real numbers. Here's the cool thing about inverses. Whatever the domain of your function is, it will be the range of your inverse. And whatever the range of your function is, it will then also be the domain of your inverse. That's because domain represents whatever the inputs are, and range always represents whatever the outputs. And remember, we're swapping those. We're swapping the x and the y. Okay, so let's go ahead and do another one. This one's a little bit more complicated. And in fact, a lot of people look at this and they panic a little bit. Why is there an x is less than or equal to 0? Well, let's talk about what this function is. If you recall, 2x squared minus 3 is a quadratic. It's a quadratic that's shifted down 3 and then has a vertical stretch of 2. Okay, and you don't even have to know all that. Just there's our quadratic, right? However, if you also recall earlier, I talked about how it's a reflection over y equals x. If we reflect a quadratic over y equals x, we're going to get something that's not a function, and we always want it to be a function. So whenever you see a quadratic, they will always put in a stipulation so that we get a one-to-one function. So in this case, what they're telling us is we're only taking the left half of our quadratic, okay? Because it's x is less than or equal to 0. This is going to be important when we talk about our domain and range and so on. In fact, they're telling you the domain. Quadratics usually are all real numbers. Because of this statement, our domain for our function is x is less than or equal to 0. Okay. Let's go ahead and find our inverse, and then we can talk about the rest of that. So to find the inverse, remember you just say y equals 2x squared minus 3. We're going to solve for x. So I'll add 3 over. I'll then divide by 2. And then we're going to take the square root. Now, when you take a square root, you need to remember that technically there are always two answers. You have a positive and a negative answer. This is going to help us know which one. Since we're on the left side, that means we want negative answers. So we're going to take the negative square root of y plus 3, all of that over 2. That's equal to x. So our inverse is equal to negative square root of y plus 3 over 2. Since I'm keeping it as y values, we're going to go ahead and talk about our domain and range. So domain, I said, is just going to be the same as the domain of the other. Now, there's a couple ways you could do the range. You know quadratics, and if you know the parent function really well, you'll realize, oh, well, this quadratic is never going to go lower than -3. So you could just automatically say, well, y has to be greater than or equal to -3. But if you didn't know that, recall in the first lesson we talked about domain without graphs. Remember, square roots, if we want a real number answer, that means the square root has to be, or the value under, the expression under the square root has to be greater than or equal to 0. Because it has to be positive. If it's less than 0, we're going to get negative numbers. So if you just solve that, multiplying by 2 just means you'll still get 0. And then you'll subtract 3, and you get y is greater than or equal to -3, which gives us the domain of our inverse, which is likewise the range of the function.